Back to our main question. This is the correct answer because of our x is x squared. So x plus change in x is going to be x plus change in x squared. All right? Are we there? All right. So just follow gradually. Now, if you open this bracket, this is x plus change in x times x plus change in x, isn't it? So let's extend this. That will give us x times x, x squared, x times change in x plus x change in x times x plus x change in x, change in x times change in x plus 2 change in x. Are we together? Are we together? Why? You don't know how to expand the bracket? If you do, then that should not be a problem. So this gives us x squared plus 2x change in x plus 2 change in x squared. Oh, sorry, this is change in x squared. All right. So this is the expansion of that bracket of this. So which means that our f of x plus change in x is this. Now we now bring it to first principle. What is first principle? dy dx is what? Limit as change in x tends to 0, f of x plus change in x minus f of x all over change in x, which is what? Limit as change in x tends to 0, f of x plus change in x is the whole of this expression. That is what? X squared plus 2x change in x plus change in x squared minus f of x, which is x squared, all over change in x. So dy dx is now equal to limit as change in x tends to 0, x squared plus 2x change in x plus change in x squared minus x squared all over change in x. Note that x squared minus x squared is out. Are we together? So if that is out, we are left with limit as change in x tends to 0, 2x change in x plus change in x squared all over change in x. All right, that now leads us to limit as change in x tends to 0. If you look at this, change in x is common. So you can factorize out change in x. You're going to have change in x into 2x plus change in x all over change in x. Are we together? So when you get to this point, change in x up there can cancel change in x down here. This will take away this. So you are having limit as change in x tends to 0, 2x plus change in x. Now, the person that asked the question about limit, when you get to this point, you are saying change in x tends to 0. So when you remove your limit, your change in x becomes 0. So your dy dx is equals to 2x because change in x is 0.